We've got these incredibly powerful AI models that can do some amazing things. But what if they could be even smarter? What if we could make them genuinely useful for complex, real-world jobs? Well, the answer, as it turns out, might be as simple as giving them the right set of tools. Let's dig into how that works. So here's our game plan. We'll start with the current blind spot that even the smartest AIs have. Then we'll meet OctoTools, the framework built to solve that problem. We're going to break down its super clever planner executor system, check out the hard data on how it performs, and then wrap up with why this is such a big deal for the future of AI. All right, let's get right to the heart of the problem. Large language models, LLMs, they're just phenomenal. But they have limits, especially when you ask them to do something that requires a very specific skill or, to interact with the outside world. And that really is the central question, isn't it? Why would an AI that can write poetry or debug code suddenly struggle with something that feels way simpler to us, like counting things in a picture or doing some precise math? Well, it all comes down to what they were fundamentally built for. Think of a base LLM as this brilliant artist who is just a master of language. It's incredible at writing, summarizing, coming up with creative ideas, but it doesn't have a calculator built in. It can't just go and search a specific database on its own. So when it has to do a precise calculation or use some external tool, it kind of hits a wall. That's just not its native language, so to speak. It needs a guide. And that is where OctoTools comes into the picture. So let's meet the framework that basically gives an AI a fully stocked master workshop, complete with every specialized tool it could possibly ask for. Okay, so the paper defines OctoTools like this, but a couple of words here are absolutely crucial. Training free. That means you don't have to go through the massive, expensive process of retraining the entire AI model just to add a new tool. And extensible means it's built from the ground up to be easy to add to and expand. This is the whole foundation for building much smarter, much more capable AI agents. So how does it do that? Well, the secret sauce is this simple but brilliant idea: tool cards. Just think of them like standardized instruction manuals for every single tool. You got a web search tool? There's a card for it. An object detector? It gets a card too. And each card tells the AI exactly what the tool does, what information it needs to run, what it spits out, and, this part is key, what it's not good at, its limitations. Okay, so if the tool cards are all the individual tools in the workshop, how does the AI decide which one to use and when? Well, that's handled by this fantastic two-part system, the planner and the executor. Let's meet the brains and the brawn of OctoTools. Here's how the workflow goes, and it's really elegant. First, you've got the planner. This is the master craftsperson. It looks at your request and comes up with a high-level strategy. It thinks, I'll probably need these tools to get this done. Then it gives a single, simple instruction to the executor, the diligent apprentice whose only job is to do one thing: generate the exact code to run that one tool. The executor runs the tool, gets a result, and feeds that result right back to the planner. The planner then looks at the new info and decides the next move. By splitting up the thinking from the doing, the whole system makes way fewer mistakes, and we can actually follow its chain of thought. Okay, theory is great, but let's see this thing in action. The paper uses this really simple visual question to show off the framework's power. Fun fact, a standard LLM actually gets this wrong. It counts 19 baseballs. So let's see how OctoTools handles it. And this is it's brilliant. This shows the logic perfectly. First, the planner thinks, okay, let's just get a general idea of what's in this picture. So it calls the image captioner tool. The caption says something like 4 buckets with about 5 baseballs each. But here's the magic. The planner knows from the tool card that the captioner is kind of bad at precise counting, so it automatically starts a second step. I need to verify this. It then calls the object detector tool, which is built for counting, to get a hard number. The two results match up, 20 baseballs. It's using different tools to check its own work and get to a much more reliable answer. That's a clever example for sure. But does this kind of smart logic hold up when you throw a bunch of really difficult problems at it? Well, let's go look at the proof. Let's check out the performance data. Here it is. This is the single biggest headline number from the entire paper.
when tested across 16 different really challenging academic benchmarks. Just giving the AI the OctoTools framework resulted in a 9.3% average jump in accuracy over the standalone GPT-4o model. And look, in the world of AI, an almost 10-point leap isn't just a small improvement. That is a massive, massive step forward.
And it's not just about beating the base model. This chart shows you how OctoTools stacks up against other popular agent frameworks, all using the exact same AI brain and tools. Over on the left, you see OctoTools hitting 58.5% average accuracy. Now compare that to the next best one, LangChain, at 51.2%. That 7-point gap shows that the framework itself, that planner-executor system, is what's really making the magic happen. And when you break it down, you see just how flexible this thing is. Look at Game of 24. That's a really tough math puzzle. OctoTools is more than 10 points ahead. But then look down at Gaia, which is a test specifically for how well an AI agent can reason and act. OctoTools more than doubles the score of its nearest competitor. This is not a one-trick pony. We're seeing big, significant gains across the board. So, okay, the performance is obviously impressive, but let's take a step back for a second and talk about the bigger picture. Why is a framework like this so important for where AI is headed? So what this all boils down to is this. OctoTools gives us 4 huge advantages. It's more transparent because we can literally read the AI's step-by-step game plan. It's way more modular thanks to those brilliant tool cards. It's just flat out more effective, and the data proves it. And it's so much more adaptable, because you can teach it a new skill without that massive, costly retraining of the whole model. You don't have to take my word for it. The authors themselves say it best right in their conclusion. They believe this work opens up whole new ecosystems for building what they call next-generation AI agents. Agents that are more transparent, more modular, and just plain better at solving actual real-world problems. And really, that's the thought I want to leave you with. Just imagine what becomes possible when you can give an AI a perfectly customized toolkit for any problem you can think of. What could you build for scientific research, for medical diagnoses, or even just for your own complex work challenges? The possibilities are just staggering. And hey, speaking of giving things the right tools, just like OctoTools gives AI the right tools to reason, we try to give you the right explainer to understand it all. And you know, the best tool in your personal knowledge toolbox? Well, that's the subscribe button. Come on, it's training-free, it's super user-friendly, requires just a single click, and it is scientifically proven by us to boost your knowledge on awesome topics just like this one. Go on, deploy Agent.